All right, there's two big problems here. One is at 0. The natural log is not defined at 0. It's sailing off to minus infinity. And the other one at 1, the bottom is going to become 0 at 1. So I got two big problems over here. The other problem is I don't recognize that, that integral, and I'm going to have to play around with it. I'm going to see if I can get an antiderivative to it. All right? So I kind of look at the improper case over here. And this really requires me to do it in steps. So let's talk about the steps that I took to get it. All right, so let's write down the original integral. I'm not going to worry so much about the improper nature of it until later, but I do want to write the limits down. But I'm not really kind of worried about, when I say the limits of integration down, I'm not writing the limits as we approach 0 and 1 down yet. So what I'm going to do over here is I'll let u equal x minus 1, and du would equal dx. Right, relatively simple. So if you were to rewrite that over there, what would you get? Let's see. If x is 0, it would start at minus 1 now. And the other problem is if we're at 1, it would be stopping at 0. And then I get the natural log of x. Well, that's going to be u plus 1. By the way, that has not improved the problem one bit. Right, really hasn't. What goes on bottom? U. And then what do you get? The dx is the du. Okay. This does not improve the integration one bit. However, I start to realize I recognize that natural log of u plus 1 as being related to the geometric series. Let's talk about that. All right? So I'm going to say you should be very familiar with the geometric series. This is this guy over here. And that's, fairly easy to write down. It's one you learned in pre-calculus, all right? This converges for x's that are going between minus 1 and 1, but not including minus 1 and 1, all right? So what I do over here is I look at, this ln, u plus 1, and I differentiate it, d du. And what would that give me? It would give me 1 over, I'm going to write a little differently though. I'm not going to write u plus 1, I'll write down 1 plus u. So I immediately recognize that it looks just like this guy over here, with one exception. It's not minus, it's plus. It's easy to write down. It'll be 1 minus u plus u squared minus u cubed. I think you get the idea. All right? Then what do? Let's take a look. I guess I just integrate it. All right, let's put that down. So I'm going to integrate this. And then I'm going to integrate the other side too. So 1 minus u plus u squared minus u cubed plus yada, 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 du. All right, let's do that. What do you get? Natural log of u plus 1. Now, you can put the constant on either side. I'm going to put it on the right side because it's easier for me. You're going to get c, some constant of integration, minus u squared over 2. Whoops, I forgot somebody first. I didn't see that guy. I'm sorry about that. So plus u minus u squared over 2 plus u cubed over 3 minus yada, yada, yada. All right, not so bad. Let's keep moving. I got to figure out the c now. The easiest thing for me to do is pick a u that will be very easy to evaluate. And I'm going to say pick u to be 0. And what do you get? The natural log of 1 would equal c. All those terms disappear. What's natural log of 1? It's 0. So now I have a really simple form of u. Let me show you that. Not show you, but write it down. So the natural log of u plus 1 is u minus u squared over 2 plus u cubed over 3 minus yada, yada, yada. Relatively simple. Now, granted, you might say, why'd I do that? I did it because I want to look at this guy over here. That's what I want to look at. All right, let's take a look. So let's figure out, wrote that down. I'm checking my notes right now, see if I wrote this down. I did. It's more extensive, though. Let's divide it by u. Every term is being divided by u now. So ln u plus 1 over u is going to be 1 minus u over 2 plus u squared over 3 minus yada, yada, yada. It's got an easy pattern to it, by the way. All right. Then the question is, what are you doing with this guy over here? It does get more difficult, but we have to integrate this guy. Right? We have to integrate it. And let's do that. All right. This is du. Now, certainly when I do that, let's see what we get. You're going to get some constant of integration plus u plus u squared. 2 times 2 is 4. I'm just going to say 2 times 2. Plus u cubed 3 times 3. I think you get the idea. All right? So we have something, we got a series at least for our integration. And I know this integration works for certain values of u. We talked about the convergence for the original geometrics between plus or minus 1. And I'm going to say it's a valid interval. Now, certainly, when I'm doing this over here, I want to say I'm really not interested in the indefinite. I'm not worried about what the c is at this point. What I'm kind of worried about, though, is how to do that integration problem. And let's write that down now. So the integration I want to do is 0, not 0. I'm sorry, we wrote that down differently. We're doing u's now. So I want to go from minus 1 up to 0. I don't have to worry about the constant anymore. The natural log of u, plus 1 over u du. I'm not worried about the constant anymore, but I got these terms over here to worry about. And what do you get? You know what? I think I copied wrong too. Let me go back and correct. Because it's alternating. And I made a mistake there by not alternating this thing. So let's see. This is going to be minus, plus, minus. Sorry about that. All right. So what are we doing over there? I'm evaluating that guy from minus 1 and then 0. Now, what's nice about this guy over here, at 0, all these things evaluate to 0. So I'll write that down. Then minus, oh boy, let's see if I can do that. And I'm going to write it down. I have to write it over here, by the way. I'll put the minus sign here. Let me get rid of the minus sign over there. And we're putting minus 1 there. So what do you get? Minus 1, whoops, sorry about that. Minus 1 over 2 squared. Let me see if I'm doing this right. Minus 1 over 3 squared. Wow, that's pretty simple. Minus 1 over 4 squared. I think you get the idea. I'm seeing something here. All right? So this goes on forever. And I'm going to say this really equals 1 plus 1 half squared plus 1/3 squared plus 1/4 squared, yada, yada, yada. All right? And then I think I recognize that guy. Right? 1, 2, 3, 4. I'm going to write this as a summation problem. So I'm going to say to sum, I'm going to write this first term as 1 over 1 squared. I'm going to say this really looks like 1 over n squared, n equals 1 to infinity. And this is a rather famous summation. I'm not going to say I always remember it. I don't. I look at sometimes say, oh yeah, I should remember that guy. I have short-term memory loss, and since I can't remember a lot of things, I can always look it up though, or just whip my calculator out and throw it in my calculator, and my calculator will know the answer to that one. All right, it's a pretty well-known function, by the way. So let's take a look, and I'm going to say that this is a famous. I'm not sure I'm pronouncing this guy's name right, Basil. The Basel problem, or Basel, I really don't know how to pronounce the guy's name. I believe it's a Swiss mathematician though. And it's a summation problem, and it's got a known sum, right? And what's that? And by the way, if you go to the YouTube, you'll see a lot of people, verifying that this is true. Pi squared over 6. And we're done. Thank you.